Hi guys, today we're going to be looking at solving equations with variables on both sides. In our first example, it says to solve, and then it has 8 plus 2.5d equals 3.5d. Now we've already been solving two-step equations where you do, where you do the left, you do the right, so on, so on. This, what we're learning today, is really nothing new. The only thing we're combining now is that we learned how to combine like terms. So we learned that numbers with numbers and variables with variables. In this case, we're going to do the same thing. So what I want to do is I'm going to apply what I've learned for numbers to variables. And so before we could get rid of things from both sides, today I want to get rid of the variables from both sides. So in this case, I'm going to go ahead and get rid of this plus 2.5d. Now remember, when we barely started learning this algebra, we learned that if it was adding 4, we subtracted 4. So same thing here, we're still doing opposites. If it's adding 2.5d, the opposite is to subtract. So I'm going to take away 2.5d from both sides. So that cancels, that becomes 0 right there for the positive 2.5d. And I am left with just 8 equals, and 3.5d minus 2.5d is just 1d. So I'm left with just d. So my final answer is d is equal to 8. Now again, just like we've been doing before, if I wanted to double check to make sure this is true, and I would plug in for d an 8, and I should get both the left equal to whatever is on the right. Okay, let's go ahead and take a look at example 2. In example 2, they have 2/3 x minus 1 is equal to 9 minus 1/6 x. Okay, so here they start talking about finding the common denominator. Fortunately, since you guys have a calculator, you don't have to worry so much about that, okay? So let's just focus on solving here. The first thing I want to do is I want to get my like terms together. I'm going to try to get rid of that minus 1. So because it's subtracting 1, the opposite of that is to add 1. So I'm going to go ahead and add 1. And I know that the book does steps a little bit different than me. That's okay. Just follow along with me. So I add 1 to both sides. So my 1's here cancel. I'm left with 2/3 x is equal to 9 plus 1 is 10. So that's 10 minus 1/6 x. Okay, now I want to get my x's together. So I want to move this minus, I want to move this minus 1/6 x to the other side. Right now it's minus, so the opposite would be to add. So I add 1/6 x and I add 1/6 x to both sides. And so again, here they had to get like terms, common denominators, but since you guys have calculators, you could just enter into your calculator 2/3 plus 1/6, and you would end up with 5/6 x is equal to 10. Now it looks like the other equations that we've been doing. So right now, remember that the number in front of x is multiplying by the x. So to undo that, to do the opposite, we're going to divide by 5/6 and divide by 5/6 both sides. So my x is going to end up equaling 12. So my x is 12. Okay, in example 3, it says that Green's Gym charges a yearly fee of $75 and then $12.5 for each section. Each session with the personal trainer. So a new fitness center charges a yearly fee of $100 and then $10 per session with a trainer. So they want to know, after how many sessions are these going to cost the same? Well, we first need to set an equation for both of them, each of them, and then set them equal to each other. So for the first one, we know it's $75 and then it's $12.50 per session. So if it's just one, it'd be $12.50. If it's two, it's 2 times that. 3 times that. So we can write that as 75 plus 12.5 per session. So I can say that that's S. They wrote S. I'm going to write X just because my S's start looking like my 5's. So then that equals, because I want those to equal each other. And the other one is $100 to start, And then each session it's $10 and then $10 and $10. So like if it's just one, it'd be just 10. If it's two, it'd be 2 times more. It'd be 2 times 10. If it's 3, it'd be 3 times 10. So I'm adding 10 times the number of sessions. From here, it's what we've been doing. So in the other one, I got rid of, I believe it was the left side or the right, I don't remember. However, you decide if you want to get rid of the 12.5 first, get rid of it first. If you want to get rid of the plus 75 first, you can do that, as long as you make sure that your equation remains balanced. So to get rid of a plus 25x plus 12.5x, I can subtract 12.5x. But since I think I did the left side first, on the previous example, I'm going to get rid of this one. Hang on, let's just be sure. What did I do? Oh no, I got rid of the left side. Okay, so let's get rid of the right side now. So to get rid of the right side, it's a plus 10x. So the opposite would be minus 10x. Minus 10x. So that cancels. That is 75 is 12.5x minus 10, and that gives me positive 2.5x is equal to 100. And so now get my numbers together. So now I want to get rid of a positive 75, and I can do that by subtracting 75. So I have 2.5x equals 25. And again, any number that's in front of a variable means multiplication, so the opposite would be to divide. I divide by 2.5. I divide by 2.5. I enter that into my calculator. How many times does 2.5 go into 25? And that would be 10 times. And so my x is 10. If I wanted to check it, I could plug in a 10 here for x and a 10 here. And when I do 75 plus 12.5 times 10, it should equal the same thing as when I do 100 plus 10 times 10. Okay, example 4. They want us to write a real-world example for this equation. So here you decide what you want your x's to be. They gave us an example here. 30 more than 1/2 of the students. So 30 more is the plus, then half of the students. That's why it's multiplying. The word of means to multiply. Half of, so it's half times whatever students, which is x. Belong to a social network. 5 less than 3/5 of the students, so that's the opposite side. 5 less is subtracting, then 3/5 of the students, so that's 3/5 times x, is equal 5 less than 3/5 of the students have an email. If this number of students who belong to a social network is equal to the number of students with an email, how many students are enrolled? So now you can set those equal to each other. So this would be an example of putting words to the equation. That's it, guys.